Hello everyone, welcome to School Math Simplified. As we are continuing our chapter number 3, that is a story of a numbers. And in the previous lecture, we have learned about different number systems and the place values. So now we are adding to our knowledge about the Mayan number system. So it comes from the Central America, and they also devote their intellectual achievements in the place value system and designed of their own, which is independently written. They have their own symbols, placeholders, and their own symbol for zero as well. Let us see here. The next picture, you will see it. So this is what we call the Mayan number system. How we read it now. So firstly, discuss about almost this is a base 20 system, and the landmark numbers are 120, 20 cross 18, 20 square cross 18, 20 cube cross 18, and so on. The symbol for 0 will be like in the form of a shell, seashell, okay? And dot for 1, a bar for 5. So how, this is how they present their numbers in vertical. So 4 dots, then this section, and then this section. So it is divided into three sections. The 4 dots, that is number 4, and then 1 dot and 2 bars mean this is 5, this is 5 and 1. So adding them, it is 11, and this number is presented 0. So how, what numbers they are positioning the landmark. So they are positioning, so the 4 dots are positioning the third, as there are three in layer, so we are starting with the highest most one. So this is the third layer, then second, and then the first. Okay, that's why the third number is 360. It is denoted by the first one, then 20, and then 1. Now how to obtain the number? You will multiply 360 by 4, 2 by 11, 20 by 11, and 1 by, and then after adding it you will get 1660, which is the number it represented here, 1660, right? And the symbol will be this, and it is presented vertically here. This is what we call the Mayan number system. Moving ahead, so what is this phenomena? The phenomena is that their landmark number is a representation as 360 rather than 400. So some scholars feel that this might have something to do with their calendars. They use a dot, a seashell, a bar for their symbols. So what about the other things? So to represent this would be quite difficult because the system is not actually base 20. So it lacks the advantage that a system with a base has the computations. So then we are moving towards the Chinese number system. So what is Chinese number system? They actually use road numerals. They use roads, verticals and horizontal. Okay. And what was their number system? This was the Chinese number system. You can call it base 10 or decimal number system. They call the roads as zongs and hangs. Vertical roads are known as zongs and the hangs are here. Actually, zongs represent the units, hundreds and 10,000 terms, and after them hangs represent tens, thousands, hundreds of thousands, etc. So these were the symbols over there. And now just you can see the pattern: 1 4 1 bar, 2 4 2 bars, 3 4 3 bars, 4 4. There is something different at the third bar here, and fifth, if something is different at the first bar, and similarly when we deal with the horizontal strips. Okay, so how do we read it? So two hangs means the symbol this, and the landmark number will be 10 cube. Okay, six zongs, the symbol, three hangs, the symbol, four zongs, right? So we are going to read this numeral now. This two hangs, six songs, three hangs, four songs. This is what the presentation of the number. This is how we read it. And the landmark number, because it is 4 in numbers, we'll start with the highest one, 10 cube, 10 square, 10 and 1. Why we are taking 10 here? Because at the starting they are mentioning it is a base 10 system. Let's multiply with them. And then after adding you will get 2634 will be the number which is presented here. So do it carefully. So now they are introducing the Hindu numerals. Hindu numeral system you are already aware of. It is a base 10 system and the symbols here are 0 to 9. Right? As you want to represent the numeral 375, so how we read it? 375, where 3 is presenting the hundreds place, 7 presenting the tens place, and 5 presenting the units place. You know how to expand it and you will get the answer. Right? This is what we call the Hindu number system. So without any delay, you can see the evaluation of the idea of the number representation here that we have done till now. So we have gone through the Mughal system, then Romans, and then many other regional number system and their landmark numbers, and then after them the number systems. So there are this is the last figure it out that we are doing now. The question number 1 is, why do you think the Chinese alternated between the Zong and Heng symbols? Only the Zong symbols were to be used. How would 41 be represented? And could this numeral be interpreted in any other way if there is no significant space between two successive positions? Okay. So see, the reason behind seems to be that they wanted to avoid misinterpretation while reading the numbers. Right? So if we want to present 41, right, 41. So in the Zong symbols, it this, would be this 41, right? So this can be easily misinterpreted as 5. If no significant space is left between the successive positions, right? This, if this will be darker, so this could be significant misinterpretedly as 5. So the spaces are the main reason between them. Now the second question is that the form of base 2 place value system using Ukasar and Urapan as the digits. Compare this system with the Gumalgal system. Okay, so we are preparing here the base 2 system. For this, we'll use some landmark numbers. 2 raised to 0, which is 1. I'm taking it A. 2 raised to 1, 2, I'm taking it B. Square, I'm taking it C. And 2 raised to 4, which is 16, I'm taking it D. So the number representation will be 1 is A, 2 is B, 3 is A, 4 is C, 5 is CA. Right? So this is our base 2 number system. And now I'm using Ukasar and Urapan here. So for Ukasar and Urapan, how do we present them? This will be like this. See here. Number 1 is Urapan. Number 2 is Ukasar. 3 is Ukasar Urapan. 4 is Ukasar Ukasar. 5 is Ukasar Ukasar Urapan. This is what is differentiating here. In this number system, we have many landmark numbers. Right? In this system, we have only 2 landmark numbers. So this is the major difference what they have asked. Okay. So the comparison was that of the landmark. So moving to the third question here. One, where in the daily life, which profession do the Hindu numerals and zero play important role? How might our lives have been different if our number system and zero had not invented or conceived of. So yes, they are useful wherever we have to read until numbers and do any calculation, right? This is important. This is useful. In case of zero was not there, if zero was not there, all the above would have become much difficult, tedious. So there would have been no computers, obviously. No zero will be there, then no computers. Why no computers? Because computer language is totally depending on 0 1 system, binary language. Okay? So obviously 0 is important here. Question number 4. The ancient Indian likely used base 10 for Hindu number system because humans have 10 fingers. So we can use our fingers to count, but what if we had only 8 fingers? How would we writing numbers then? If we have only 8 fingers, the numbers will be 0, 1, 2, 3, 4, 5, 6, 7. Numbers will be only this, okay? And if there will be 5 fingers, so it will be 1, 0, 1, 2, 3 only, right? Yes, we use 10 digits 0, 1, 2, 3, 4, 5, 6, 7, 8 up to 9. These are the 10 digits. We have 10 fingers, so we count it on there. If we have only 8 fingers, then we will use these numbers. If we have only 5 fingers, then we will use this. So they are asking now, try writing the base 10 to numeral 25 as base 8 and base 5 Hindu numerals respectively. Can you write it in the base 2? Do it. How to this question now? Doing it here. You are going to present 25 as base 8. So divide 25 by 8, 3 is a 24 and you will get 1 remainder. Fine. So 35 according to the base 10 can be represented as 3 1 base 8. This is a way solve this. How to do it? 25 को 8 से divide करके quotient and remainder you can write here. So 3 1 quotient and remainder is this. 3 1 the base 8. You can write 25 in the base 8. This is the base 8. What if we need to present 25 to the base 5? 5 5s 0 will be the remainder. So when you are presenting 25 base 5 system, it will be 50. 50. And also quotient. They are asking if you can represent 25 to the base 2. Do it. When you divide quotient, remainder, divide quotient, remainder, divide quotient, remainder, and divide quotient. So 35 to the base 10 can be presented as quotient, remainders. This will be the so when you are presenting 25 as a base 2. So with this we are ending this chapter. The summary is given to you. You need to go through with the summary points also. Right? As these all are very important for the MCQs. Don't skip this part of your book. Do it, read it, and if you feel any doubt, you can ask in comment section. Thank you very much.